Welcome everybody to our session today. It's going to be really exciting. I know you're probably like me, and that we get very distracted in our day-to-day lives about the things that we're working on, and it's sometimes very easy to lose track of some of the other things that are going on across the industry. And so today we're going to have a really good opportunity to find out what's going on with some great vehicles and some missions that they potentially can fulfill in a lot of different ways. And of course, we're all sort of converging that Mars is a very interesting place to go. We've known that inside our community for a very long time, and it's just been a matter of getting the outside world to go, hey, that really sounds like a good idea, and we'll talk about that, and as well as what's going on internationally and how this all ties together. So we've got some great panelists up here. I'm going to take a moment to introduce them. I probably ought to introduce myself. I'm Sandy Magnus. I'm the Executive Director of AIAA, former NASA employee. So I'm actually very interested in learning about what's going on too, because again, I get tied to other stuff during the course of my current job. So let me take a moment. This is going to be a standard sort of format where everyone will have an opportunity to present some thoughts, and then we'll have a conversation. And I really, really hope we can make this informal, conversational. I hope that you feel very comfortable asking questions, and we can have a good give and take as we go through the course of the next few hours. So that's kind of the format. And let me take a moment to introduce the panelists. Steve Creech, immediately to my right, is the SLS Strategic Development Manager at Marshall Space Flight Center, and he's been doing spacecraft payload, international, and the evolution of the, what is that word? I can't read it right.
It's cheating, Sandy.
I've got a new job, so it's changing my title there, but that's okay. That was deputy manager.
I can't read his writing. Deputy manager. So actually, your new
This
title
is
is
very conversational.
Spacecraft Payload International. I'm a very informal person.
Yeah, that's
and
integration.
Integration, evaluation, deputy manager. Okay. Basically, Steve is going to talk to us about the Global Exploration Roadmap and how that plays into what's going on currently with the SLF and the Orion and where that could all go. And that ties in the international piece. And then next to Steve is Harley Thronson. He's the senior scientist for advanced concepts in astrophysics. And he has been doing a lot in the assessment of advanced human and robotic programs in coordination with all of NASA's centers, academia and industry. And so he's going to be talking to us a little about affordability and the context in which we could potentially go do some of these missions that we'll be discussing today. And then next to Harley is Larry Price, who is, hang on, I got to look for my notes. Larry is the Orion Deputy Program Manager at Lockheed Martin, and in the past has worked with the Air Force on shuttle payloads and Athena launch services, and he'll be talking to us a lot about the Orion. Next to Larry is Charlie Lundquist, who's the Crew and Service Module Manager of the Orion program at JSC, and there's going to be a lot of overlap, and everyone's going to be bringing a different bit of a perspective about where we are with the testing and the design and the mission. So you'll hear a little bit of everything from everybody, which is good because it'll keep it nice and conversational. Charlie is down at Houston. And then finally, next to Charlie is Dawn Stanley. And Dawn is here as a System Engineering and Integration Technical Manager for the Space Launch System, and she'll be addressing some Space Launch System current activities and future activities. And so I think we're going to have a lot of information to absorb today, and it's going to be very exciting to think about where the future of exploration is going. You know, we have a very vibrant industry. There's a lot going on, and I will turn it over to Steve to set the framework with the Global Exploration Roadmap and how that ties into international activities.
Good morning. Thanks, Sandy. So I get the job of the fun part, the bigger picture and what's going on from a mission standpoint in the international community, and something we call the Global Exploration Roadmap, or GER. Before I get started, let me first of all give credit to Kathy Larini. Kathy is our leader for the GER activities. She couldn't be here today, so I'm going to stand in for her. I actually lead our international activities on SLS and support her in all those studies, so credit to Kathy. So If you haven't heard, what is the Global Exploration Roadmap? First of all, we know that exploration and beyond LEO exploration is going to be an international endeavor. Just like our human exploration program today on ISS is an international endeavor, we know that exploration needs to be an international kind of program, and there's lots of reasons we need that, affordability being a big part of it. So this roadmap is a mechanism we use that multiple agencies can figure out how they're going to contribute to the mission. We'll take the lessons learned from ISS. They'll contribute based on their capabilities and based on what kind of long-term interests their individual countries and agencies have. You might have seen Mars journey, or NASA's journey to Mars. That's kind of the top-level strategy that NASA's laid out. That the research that's going on station now to prepare the way, but we're Earth reliant. That we'll do proving ground missions, and then finally to be Mars ready. That was developed in consultation with our partners. And so that was not a NASA only thing. That was they're in line with that. The Global Exploration Roadmap, though, is a more detailed version, non-binding, but to use for communication and so that we can have a common roadmap between NASA and these international partners. So even though these missions are out in the future, what this roadmap does is it allows agencies, when they're making decisions about investments and capabilities they're interested in, that they're informed and they can lead to future partnerships. You're going to see in a second that the GER is a stepwise approach consistent with that Journey to Mars strategy, and that the next step is lunar vicinity or cislunar space kind of missions as the first beyond LEO missions. You might have seen, if you've been following this, there was a previous version of the Global Exploration Roadmap, and in that there were kind of three different alternatives. There was an asteroid first strategy and a lunar next strategy and something else. So the strategy now, there's one pathway, there's one journey, and that's all through lunar vicinity. So NASA and the international partners are continuing the dialogue. Kathy was leading our delegation. There was actually a meeting in Tokyo last week, and those are ongoing. There's another one coming up in Europe this fall at the senior management level. Gerst and Mr. Gerstenmaier, our associate administrator, and his counterparts, they meet regularly. They'll be meeting at IAC this fall. So here's the mission scenario for the roadmap. So this is kind of an eye chart, but I'll talk you through it because this is sort of the heart of what the teams have been doing and working together. First of all, you see on the top, as we stated, and if you saw the session this morning, our flight program for human spaceflight now is, of course, is the station, and we're not even bigger than or in addition to all that we're learning there, and that is a flight program. That's where all the international partners are. So that'll continue. That's the foundation that allows us to be able to do beyond LEO missions later. So in the beyond LEO mission area, the first is, you heard about also this morning, is the asteroid redirect mission that'll be in cislunar space. Then after, you can see the milestone on here actually before the return of the asteroid is an extended crew duration mission. And so that is with a deep space hab that I'll talk about in a second. So we'll be doing missions in cislunar space in that vicinity with both the asteroid and with a deep space hab. That'll lead to, and you'll use that deep space hab capability to do lunar surface missions. Just as the international partners, they see the asteroid redirect mission is valid, but it's not what they would choose first. While we don't think lunar surface missions are necessarily required, our international partners do, and so we see in the whole that is important. So you'll do lunar vicinity, then lunar surface, and then for Mars you'll have the same kind of cadence of Mars vicinity and then Mars surface. A few other things to mention is that, you've got a lot of these small dots on here, so there's been a lot of interaction and integration between our robotic and science program and the human program to make sure those are well coordinated and leveraged. And so a lot of the robotic missions are preparatory missions in what we're learning, of course, to do human missions. A few things I'll point out on here that are kind of interesting, or I think very interesting, is in the GER construct, they are looking at human-assisted sample return missions that you see on there for both lunar missions and for Mars sample return. And so you would use the Mars vicinity, Orion and SLS in that vicinity in the Deep Space Hab to be able to do sample return missions, which particularly for Mars is something that's long been a desire. You also see in the Mars mission swim lane there that another robotic first mission that we feel like needs to be done is entry, descent, and landing of a human scale kind of lander technology. The other thing I point out that's common across these is just as commercial opportunities in low Earth orbit that NASA's doing with Station, we see that there are going to be commercial opportunities. In addition, we're not just leaving commercial in LEO. We think there's going to be opportunities in these beyond LEO missions also. Along the bottom is what we're calling multi-destination transportation capabilities. These are the systems, the capabilities that different agencies are investing in that allow us to do these missions. And so these capabilities then are being designed and developed to be able to do all these missions and enable this whole roadmap. So first, of course, is SLS and Orion that we and NASA are doing. We're developing those systems with the DRMs in mind all the way to lunar surface missions. So with SLS and Orion, you can accomplish this, all of these type missions. You see the next thing on there is a Russian piloted system. The Russians have interest in having a beyond LEO transportation system. And if they can afford to do that, we think that's a good thing. Station has taught us it's good to have some redundancy in our transportation systems, and so that's their intent, and that's on the roadmap. Then you see advanced electric propulsion, of course, that's being developed in the ARM mission. I mentioned the evolvable deep space habitat. This is an area that the ISS partners are naturally fitting in and talking partnerships. And of course, we're doing long duration kind of technology investments in our AIS program. Then you see the landers. Next thing we'll need is landers. I mentioned these human lunar surface missions. The intent is that when that's done in the systems that are being studied now to do those missions, that it be feed forward to Mars. It not be a end into itself, but we're using the right kind of propulsion, the right kind of sizing, the right kind of systems that we're actually proving out the capabilities we need to go to Mars, not just do that particular mission. So, that's the capabilities. So the other thing I'll mention is this kind of takes each of those mission areas, and you'll see, and if you go read the document, that it talks the capabilities that are needed to do those missions. It talks about what we're going to learn, what science objectives, what exploration objectives you're going to get out of the mission. And then the other thing I wanted to point out, though, is in the top right there is the tie of what we're learning to allow us to go to Mars. So we don't want it to be, obviously the strategy is not to be a dead end, that we have to take a stepwise approach, but it needs to be steps toward Mars, not ends into themselves. So I'm not going to brief this in detail, but this is something else you'll see in the document, is taking each of those capabilities that are needed for a Mars surface mission, how they're being, technology investments that are taking place on the ground, that are being flown on ISS, the lunar vicinity missions, and so on. So that gives you, I'm going to turn it back to Sandy, but that gives you an idea from a international human exploration standpoint, the discussions and the road mapping activities that are taking place for planning for Mars. Thanks, Sandy.
Very good. I believe, so we just, Charlie, I think you were next, right?
So, with all due respect to my colleague Steve, I think I get to talk about the most funnest part.
We all do.
Because I get to talk about actual hardware. I got some pictures, and my name's Charlie Lundquist. I work at the Johnson Space Center. I'm the Crew and Service Module Lead for the Orion program, and I'm going to share with you today the status of the Orion program. So first I thought I'd start off by giving you a little background on what is Orion. Orion is a key component of the overall exploration architecture that we need to go beyond low Earth orbit. Orion gets access to space. We get our ride on the Space Launch System, which Don is going to talk to you about shortly. It's comprised of three major elements. You've got the launch abort system, which is only there for the first 8 minutes of the mission. It's there when you have a bad day. Either an abort on the pad or during ascent. The dynamic phases of flight are always the most dangerous. We have to have a means to get the crew to safety in the event we have a bad day. The launch abort system, within milliseconds of picking up where we have an issue or emergency situation, it'll extricate the crew module to safety. Nestled in between the launch abort system and the service module is the crew module. The crew module provides safe haven. It provides a safe habitat for the crew during the mission. We can support up to 4 crew for 21 days. The crew module provides all the life support systems and consumables that the crew needs. It also provides a docking port, which we'll need for later architectures. And it's the only part of the entire stack that survives and comes back home at the end of the mission. And it's recoverable. And then at the bottom, we have the service module. The service module is a real workhorse of the spacecraft. It provides the propulsive systems that we need for orbital insertion, attitude control, high-altitude ascent abort. It also provides the consumables we need for a long-duration mission, oxygen, nitrogen, water. It generates and stores electrical power. You see the arrays there. The service module and the crew module stay mated together for 99.9% of the mission. They separate only right prior to reentry. The crew module, of course, reenters to bring the crew home, and the service module reenters and burns up. A few years ago, we formed a collaboration with a European Space Agency, so we have an international partner now on Orion. They've agreed to provide key components of the service module for forward missions. So we're looking forward to that collaboration. So here she is. This is a picture taken about a month ago of that's the crew module suspended up there in the high bay, the ONC facility out at the Kennedy Space Center. We're very near completing the build and assembly. We should be completed with the build by the end of this month, and we'll be transferring it over to the ground operations crew who'll be responsible for integrating the Orion systems onto the Delta IV Heavy rocket, which will be culminating in launch later this year. I really like this shot because it has a good view of the heat shield. That is the largest heat shield at 5 meters ever built. So we're excited to see how that functions for us. This shows a crew module being lifted and positioned. There's a service module in the background, and they've subsequently been mated and completing the processing. So, why are we doing this flight test that I'm talking about? Well, there's a lot of reasons. There's a lot of key technologies we need to demonstrate for extending human presence beyond low Earth orbit. I showed you the heat shield on the last picture. Re-entry is one of the most challenging of the dynamic phases of flight. We have to slow a spacecraft down for a lunar mission, about 25,000 miles per hour to a soft touchdown. For a Mars mission, it's even more challenging, up to 27,000 miles per hour For the metric geeks, that's about 12.5 kilometers per second. And so you generate, obviously, a lot of heat when you're using an aerobraking system to slow yourself down. For the upcoming flight test, we're going to be on the Delta IV Heavy rocket, get up to about 3,600 nautical miles, and we'll be able to get up to about 4,000 degrees Fahrenheit on our thermal protection systems. It's going to be a very good demonstration of the technology that we have developed. So the aerobraking system that I showed you, the heat shield, slows you down from those speeds to about 450 miles an hour. You still got to have a soft touchdown in the water. That's where the parachute system takes over. About 7 miles high is when you initiate the parachute deployment sequence. There's 11 parachutes in total that are deployed through the descent phase, culminating in the final 3, which are 3 large ring seal mains, 116 feet in diameter, and they will bring the crew module with the crew safely down to about 25 feet per second for landing in the ocean. Once we land, we need to demonstrate we can recover the crew, and we also want to recover the crew module because we want to reuse several components within it to lower our costs. This picture was taken just a few days ago, about 200 miles west of here. There's a Navy LST ship there that was successfully demonstrated ability to recover the crew module in both calm and rough seas, and so we were really pleased about that. The orange balls there you see, beach ball looking things on the top of the crew module, those are the uprighting system. About half the time the crew module lands, it'll actually flip over upside down, and that's not good, so it has these bags that self-inflate and upright the crew module. Then last but not least, we also need to demonstrate our deep space communication systems. Orion will have, our next flight test will have a guidance navigation and control system. Mission control will be up and running from Houston, and they will be able to command and control the spacecraft through the flight test. So, mark your calendars. It's not too far away, December 4th, 2014. That's our launch window. As I mentioned, the hardware's built. We're turning it over to ground operations. Can't overemphasize the importance of this flight test for us. We intend to take the data that we learn and feed that forward into the next iteration of the design. We also intend to look at that flight data and make sure it syncs up with our models. We need to reduce our risks, and this will also help us reduce our costs going forward. So we're looking forward to it.
Thank you very much, Charlie. And Don will next update us on the other half of the system.
Here, I'll let you just close it.
Well, Steve's talked about the big picture, and Charlie's talked to us about ETF-1, and I'm going to talk about exploration missions 1 and 2 and how they fit into our Mars strategy. NASA has adopted a stepping stone or building blocks approach to Mars through 3 main phases of capabilities and experience. Earth Reliant, which is where we are now, Mars Ready, which is where we want to be, and an intermediate step we're calling Proving Ground. And in order to move beyond our current Earth-reliant capability, NASA and its partners will need hardware and technology such as in-space propulsion, closed-loop life support, deep space navigation, in-space and service habitats, and entry, descent, and landing systems. But we first need a launch vehicle and a crew vehicle, which SLS and Orion are the first critical components of our Mars architecture. And we need to start testing them in a proving ground scenario, which leads us to the exploration missions 1 and 2, which will demonstrate that we can live and work further beyond Earth than we have ever been. EM-1, which is exploration mission 1, is the first mission of SLS. Its first mission is a payload of uncrewed Orion spacecraft with a circumlunar mission. This mission profile is similar to what might be used in a future asteroid redirect or similar mission. EM-1 will travel farther beyond the moon than any other human spacecraft, and currently plans are for a 26-day mission. The vehicle uses an interim cryogenic propulsion stage based upon a Delta IV cryogenic stage and will travel to a lunar distant retrograde orbit. The mission will demonstrate system performance prior to the crewed flight. And some of those areas that will be demonstrated include the Orion software, our guidance, navigation, and control, the heat shield Charlie talked about, recovery operations, as well as the SLS systems. We'll also be demonstrating high-speed re-entry at about 11 kilometers per second, which is about 25,000 miles per hour, which will be comparable to deep space re-entry. Our second mission, Exploration Mission 2, is the second mission of SLS. It will be the first crewed flight of Orion and has a circumlunar mission similar to EM-1. EM-2 will demonstrate long-duration crew operations sufficient to rendezvous with a deep space HAB for deep space missions. A Block 1, or the 70 metric ton SLS vehicle, with a human-rated ICPS and a crewed Orion will enter lunar orbit and test critical mission events. EM-2 will demonstrate the crewed flight beyond low Earth orbit and performance and effectiveness of human system interfaces and technologies on both human health and performance. A translunar insertion will place Orion in a lunar flyby free return trajectory. Now, beyond EM-1 and EM-2, NASA is planning an asteroid redirect crewed mission that you heard in the session this morning from Michelle. It combines NASA's technology and human exploration efforts in a proving ground mission that serves as an intermediate step between Earth operations and a human Mars mission. It uses Orion and SLS. It tests solar electric propulsion, trajectory navigation systems, new spacesuits, rendezvous and docking operations, and sample collection. It affordably lays the foundation for future missions. It lets us test new systems and capabilities and assist lunar proving ground arena between the Earth-dependent and our Mars-ready areas of space and capabilities. Now, from the SLS perspective, EM-1 and EM-2 provides for us and prepares for us for Mars in several ways. These missions will provide a real operational test bed and validation of our engines, our core vehicle, avionics, payload interfaces, manufacturing facilities and processes, our workforce, our supply chain, transportation, propellants, and other aspects, which will pave the way for our evolved Block 2 configuration that will put 130 metric tons in space, which is the capability we need for Mars. The EM-1 and EM-2 core stage is the core stage for Mars. A significant factor in our trade space was volume. SLS was designed around a 10-meter fairing for habitation modules and other large systems. The addition of a large upper stage and a 10-meter fairing, along with other advancements, will enable our missions to Mars. The 70 metric ton Block 1 vehicle for EM-1 and EM-2 is designed to evolve to this Block 2 configuration. The EM-1 and EM-2 SLS vehicles will be instrumented with thousands of sensors that will validate our design. And today, I'm proud to say SLS is on schedule and on budget and on track for our critical design review, which is scheduled for mid next year. And we're also on track to deliver our hardware in support of a December 17 launch readiness date. I look forward to further discussion.
Thank you, Don.
Am I going to be able to turn this on? Price. Good morning. So Charlie told you about where we are right in the near term with Orion, multipurpose crew vehicle, and Don about where we're going with EM-1 and EM-2. And I'm going to show you a few slides on concepts for where we're going beyond that point, and to really make the point that while we're designing the multipurpose crew vehicle, we really are multipurpose. And there are a lot of concepts going on in different agencies that are looking at things to do what's next in the stepping stones to fulfill what Steve talked about at the beginning. So in these cislunar regimes, the L2 neutral gravity point is really interesting to be able to sit behind the moon that we don't know much about because of the rotation of the moon. So there are people like David Kring at Lunar Planetary Institute that are looking at rovers. I think the Europeans are very interested in rovers too, where you can sit on the backside of the moon and do meaningful research with a rover in close proximity operated by a crew on the vehicle. Also, people are looking at putting a secondary payload deployable capability up underneath the launch abort system on the front of the Orion. This capability was originally developed to house a docking adapter to be able to go to the space station. So we have room up underneath the truss that supports the launch abort system that Charlie talked about that we can use for deploying spacecraft that could then go land on the moon in the same mission that you send the Orion capsule up for. Another picture with the JPL concept with a rover on the surface of the moon. We made the cover of Aviation Week. NASA did with the capability, so I think it's our second cover on Aviation Week so far, coming up with, as Charlie mentioned, the very important mission in December. Steve talked about some operations transitioning space station elements into a habitat module. This is actually an orbital capsule, cargo capsule that could maybe be extended into a HAB capability as we, as Dawn is mentioning, develop all the capabilities to be able to transition to Mars long duration capability. Asteroids. Asteroids are interesting, asteroid redirect and such, but be able to get over to an asteroid. So people are looking at a lot of capabilities to use SLS and Orion for reasonable duration missions at the asteroid in addition to the rendezvous mission. This is a little more complex. You like all those zeros and ones transmitting? A more complex mission on the backside of the moon. These are really interesting because if you sit back at a neutral gravity point, you're behind the moon but coming around the moon on occasion to be able to have direct contact communication with the Earth. In other adaptations, guys have been looking at adopting two Orion capsules together so that you can not have to develop maybe a habitat module, use another Orion that all the engineering exists for, and just not outfit it with all of the electronics, Earth ECLSS systems, and reentry capabilities. And with a smaller crew can significantly extend, Charlie mentioned 21-day crew of 4, to a very long duration mission with 2 and be able to do early asteroid redirect missions. So again, the point that at the beginning of the program, looking at various capabilities so that Orion can truly be a multi-purpose capability. Then eventually this one is the moons of Mars. Phobos and Deimos are very interesting places to be able to rendezvous and not have to go into the energy well to land on the surface of the moon and do very meaningful robotic, telerobotic operations and long duration capability before the other elements are rolled into the program. So that's just a few of the applications transitioning into what Harley will tell us about how we can economically get there and execute these missions. Did I do 6 minutes?
Very good.
Got a little bet going here.
I threatened him, he showed up with 10 slides, and we said 5. It's like, Larry.
I don't follow instructions.
Thank you, Larry.
Great, do I get his time?
No. Okay, Harley, you're up.
Oh, thank you so much. Oh, my. Here comes Mr. Sunshine. Thank you so much. For those folks who heard my talk on this topic yesterday afternoon, bit of apologies. This is going to be a distillation of yesterday's talk, which in turn was a distillation of an extensive report that a workshop that I co-led wow, what do you know? About 6 months ago. Here, we're getting there. God, I hate Bill Gates. So in fact, as I said, yesterday afternoon was a distillation of a much longer report. I'll give you the reference to it in just a moment. So what you're seeing here is sort of the Reader's Digest version of a Cliff's Notes version of a much longer report. I recommend that you read it. Also, we've got at least 3 of the folks, in addition to myself, were in the workshop about which I'll be speaking. Jeff, Sam, and Sandy over there. There may be a few others. Steve sent one of his minion to this meeting. About a year ago, probably more like about 18 months ago, a group of us got together meeting at other workshops and so on and so forth, and came to the conclusion that the most ambitious and what NASA sometimes refers to as either the ultimate or the horizon goal for human spaceflight, at least so far as was laid out by most, not all, of the architectures, was simply unaffordable. Given the current environment, maybe given current budget environment, maybe given almost any budget environment, but quite simply was unaffordable. So we proposed, the planning team proposed the first in a series of workshops, community workshops, attempting to address this. I'll be describing some of the recommendations that came out of this December workshop. That December workshop at George Washington University did not get into, although architectures and scenarios and technology, since it was mainly engineers, they loved to talk about it, was not primarily to compare those various architectures and scenarios one against another, but instead to look at management plans, options, investment strategies, coordination among the players and so on, more policies, programmatics, politics, but in a good sense, that would enable a much reduced cost, more affordable human missions, or at least initial human missions to Mars. So I'll be talking about the results from the December workshop, mention when I close an upcoming workshop in October. The co-sponsoring organizations up there involved roughly 100 NASA, non-NASA, a few international community representatives. We chose the participants there to represent, it was a workshop, so it couldn't be all that big, to broadly represent the various interest groups inside and outside the government, some academics as well, so that whatever recommendations came out of its findings, recommendations, observations that came out of this would be in the spirit of the community speaking to NASA and NASA's industrial partners. Again, it was a workshop, 100 folks more or less involved. It wasn't, we do not claim, this did not claim to be the entire community. It intended to be representative of the community. So far as we know, this is the first time that anything quite like this had been attempted, a community recommendations and findings with respect to Mars architectures. And there's, as I note down at the bottom, quite extensive briefings of those results to decision makers inside the Beltway and elsewhere. We're a really good-looking bunch, as you can see. I'll pause, let that sink in. I already mentioned the first bullet. Second bullet is just logistics. Third bullet, I already said this was not a comparison of architectures and plans and scenarios. It was a policy issues and management and so on and so forth. And there's the formal reports available. I'm pretty impressed. I co-led the planning team, but I did not do much of the writing. We let the community speak through that report. Okay, one of the most interesting discussions that we had was in the lead up to this, and that was, what do you mean by affordable? What does it mean by affordable? I mean, it's much more than less expensive than what you're doing now, because less expensive than what we're doing now may itself not be, may be affordable. So have to credit Sam Shamimi for, and discussions with the rest of the team, for this simple point. Affordable simply means it's an activity that somebody is willing to pay for. It's not quite the tautology that it sounds. That is to say, and as you'll see in just a moment, we also discussed, what do you mean by sustainable? And in the case of sustainable, most of the work on architectures for human missions to Mars concentrate, I suppose quite appropriately, on engineering or technological sustainability. Okay, totally fine as far as it goes. This workshop was dealing with programmatic and political and management sustainability. How can you organize yourselves and all other stakeholders and folks who are paying for this thing to make it politically sustainable? Back to this issue about affordability. The reason that that is not, as I said, a tautology is because that led directly to a, perhaps the most, the bottom here, perhaps the most important recommendation that came out of the workshop, and that is, in contrast with almost all, there's a couple of exceptions, almost all of the scenarios and architectures that are presented for going back to the moon, if you will, but in this case, going on to Mars, are devoid of credible discussions about who's going to pay for it, how it will be paid for. And that's more than just cost estimates. Cost estimates, more or less credible, but who is going to be paying for this thing? Arm waving about, we're going to commercialize it. Public-private partnerships is not what is being requested here. For scenarios, architectures, and so on to be taken seriously, a level 0 requirement, in fact, perhaps at the first level 0 requirement, should have not only a detailed discussion of cost, but a clear, notice the emphasis, identification of who is going to be paying the bills. That is almost never done in the scenarios that this group is familiar with. Almost never done. Some selected, and I emphasize selected, findings and recommendations, and I think there'll be one more slide after this. Incidentally, these are almost direct quotes from the report. If folks want to ask during the general discussion what they mean or what is behind them, happy to answer. So this is, as I said, distilled, although almost directly quotes. Initial human missions to Mars are affordable, but only if a handful of principles are strictly observed, and there's a modest increase in budgets for space exploration. 3 individuals who were on the recent NRC report on the future of human spaceflight participated in our workshop. They almost came up with the same, on their own, independently, almost came up with the same observation and recommendation that all plausible architectures for human exploration of Mars is unaffordable unless there is at least a modest increase in the NASA budget, as well as the budget of potential participating activities. Bullet number 2 is a challenge to probably many of the folks here. It certainly was to many of the folks at the workshop. If there's a human spaceflight activity, whatever it is, investment, precursor, whatever, that does not directly support human exploration of Mars, is very likely to be a costly and schedule distraction. You will not get to Mars in the 2030s, a popular time frame, if you spend significant time and money doing something other than investing in or developing the capabilities for going to Mars. Bullet number 3, you got to make some tough decisions real soon. Bullet 4, not only should your budget or should your cost be affordable, but once you think you have the money in place, your program is going to have to build to the available budget, which is something that is really difficult. I was for several years the program scientist for the James Webb Space Telescope. That did not exactly build to budget. This is not something that's particularly easy to do. Second to the last bullet, something that is very rarely done in the human spaceflight community. This is part of the human spaceflight community. This, involves with some of this criticism. Broad and deep community involvement. It's not merely presentations at Space 2013, 14, 15, and so on, but it is actual involvement of a broad community in developing developing and vetting the scenarios and the goals and the architectures. And a specific recommendation, the last bullet there, some type of interim or cislunar habitation facility. There has to be the next big stepping stone after the space station, the first one, and ARM has got to be designed and developed soon. Almost every scenario that was taken credibly by this group had that as the next big stepping stone or milestone, and it should be under the direction of the space station program, which has that kind of experience. Last slide, there's going to be, the next workshop in the series is going to now compare. Most of the folks who are going to be attending have been invited and have accepted, going to be side-by-side, face-to-face comparison of the major, relatively recent architectures for sending humans to Mars, with the purpose in this case of identifying areas of commonality or where there's disagreement, and attempting, we'll see how it goes, attempting from a community perspective to identify and recommend to NASA those architecture elements which look to be most affordable, most doable on the time frame of, say, the next 20 years when we want to get people to Mars. So, happy to answer questions, and I think the conversation begins.
Absolutely. Thank you very much. So you can see we just got a perspective that covered a broad gamut of policy, affordability, organizational, capability, technical, and so it's really kind of exciting because we could go in a lot of different places with this panel, but I think we'd like to start big picture and then dive down into some of the details with the capabilities and then open up to questions. And hopefully, as we have this ongoing conversation, you'll have some questions. And just to set a baseline real quick, Steve, you talked about the Global Exploration Roadmap. Could you enlighten us to who's all participating? I believe, I understand that it's the space station group plus a few extras. And could you just outline that so we know how international that particular effort is?
Sure. It is all of the space station partners, plus the Ukraine, India, and South Korea, I believe, were in this global exploration roadmap work I showed today. China is now participating. They're not reflected in the roadmap now, but they are a part of the group, and the next go-round, they will be participating also. So I think a total of 12 agencies.
So it's kind of interesting, just to comment, you know, how we built on what we've accomplished with Space Station in the international arena and pulled in more people to take the next step. And so Larry and Harley and Steve all discussed the possible things that we can do with the capabilities that we're acquiring with Orion and SLS, as well as pointing out capabilities that we're going to need and a lot of different things we can do with it. And so I think the trick is how you go from, okay, we have these ideas, we're building this stuff, and we have in the U.S., you know, this idea of the arm and then going to Mars, but we see in the international community the cislunar idea of maybe going and spending a little bit more attention on the moon. So how do we take this out of a vague, we've got these ideas, into actual agreements and a way forward? And does this happen in parallel, you know, where we're developing SLS and Orion, meanwhile someone's doing a deep space hab to put in cislunar space, and as we're going to get the asteroid, another country's working in cislunar space. So how are the conversations going? And probably for the three of you, this is a good way to address it. How do you see that progressing as we go from this idea internationally and this idea domestically of what to do with these capabilities and putting that into play, and what the timeline is, and what are the drivers for that as we develop the capabilities of the Orion and SLS, which will be going on in parallel as perhaps some of these other conversations need to take place? I'll just throw that one out. That's a lot, but.
Let me start. Okay, I'll jump in first. A couple things I'll say. First of all, it's an SLS guy. I think the current approach to implement the administration's, number one, desire to do an asteroid mission really fits well, because it gets us around a cislunar capability kind of performance metric. So the fact that we're robotically capturing and bringing back the asteroid to cislunar space, now, instead of having to send SLS and Orion to there, and then you got to have a long duration, you got to come back, that was much more difficult and not really within our current capabilities. But the way it's lined up now kind of brings us internationally, in my view, together, that all of these missions are taking place from cislunar space. And so from an SLS standpoint, you know, it's the same rocket that we're going to use for both missions, and I imagine for Orion. So I think that while it may have seemed like a disconnect, I think that the current approach and NASA's plans really fits well with the internationals. The other thing I was interested in, and I actually talked to Kathy about the latest status of this, is if you notice on the roadmap that actually the HAB is falling on a milestone earlier than when we're planning on actually exploring the asteroid. And so that is where the international partners' main interest is. And so yes, in parallel, we're seeing that the international partners, that's something that they're interested in doing. So yes.
Harley or
Yeah,
Larry,
sure.
do you want to address that?
I don't know if that's.
I think it's always
You're
on.
on.
You're always on.
Okay, that's my answer.
Go for it. No, you agree
There's a
with-
little bit of truth in that. Any case, very simple. I have my own opinion, but in this case, since invited to speak because of the Affording Mars workshop, I'll give the answer, which I think is the right one, relative to what you're talking. Take the agreements developed for the International Space Station, white out the parts where it says International Space Station, and put in Mars exploration and milestones along the way. I think the International Space Station is an excellent model. Things you would want to change, of course. An excellent model It's a stepping stone, of course, not only technologically as an engineering and a science point of view, but it's a stepping stone for international agreements. Pretty straightforward.
Larry, would you like to add anything?
Well, yeah, I think all I would add is that in the near term, Charlie and I have been focused on and Dawn on the near-term pieces, right? And I think it's excellent that there are a lot of studies going on. There's talk about what our mission needs to be and narrowing it in. And I think we need to do that and converge on it in parallel, like you said, with what we're doing and demonstrating to the leadership of the world, our country especially, that we are capable of doing this work. And I think Ares 1X and the flight this fall is going to establish the groundwork with Congress and the administration that NASA and the international community have a plan. It makes sense. We're moving forward in a metered, affordable way and converging on the work we need to do. So I am extremely excited about where we have come in, say, the last 5 years and focusing on where we're going.
So you think the milestones that we're going to be achieving with EFT1 and EM1 will encourage the parallel path to activate and get implemented with review voice from a deep space hab work, or is there someone internationally actually working on a deep space hab already?
So those discussions are ongoing now. You know, what the Global Exploration Roadmap and those discussions do is it gets that, it's a group of agencies, not countries, right? So from NASA and the other space agencies are talking about what our future plans are, converging on those. Then, of course, they have to go back to their governments, their stakeholders, and get funding and plans to do that. So we're not to that point yet, but you know, I'd echo what Harley said, that you know, that team, that space station team internationally, not only has the capability technically, but they've got the relationship of how to work together to go and do that. So definitely, I echo, I think that was a good recommendation of your group, Harley, that you know, we're working on the technology things in-house also, but there's a group there that can you know, play a big part in Beyond LEO.
Yeah, I think that's one of the intangible benefits of the space station that the space station program that we have, is that you've established this framework for how we work together internationally. But coming back maybe down a little bit more into the detail, and the you know, the crux of all this is demonstrating that we have two good systems to move forward with. Charlie, you mentioned EFT1 and some of the milestones you're trying to achieve. By the way, I agree with the whole "it's not bad when you land upside down" concept. Yeah, so.
If you don't stay there long.
What milestones, you know, given that you're trying to approve some things with EFT1, and I think your next launch would be as part of EM1, if I'm not correct. What milestones are you then going to do on EM1 to set up for Orion to be ready for a crewed flight? What's sort of the next set of milestones that you're trying to go with the EM1 to the EF2 from an Orion viewpoint?
Oh, they're on. Okay. Yeah, so great question. EFT1, we're demonstrating approximately 80% of our critical flight systems on the next flight, but it's uncrewed. We're not going to have our life support systems installed. So we're going to be demonstrating, we're going to build incremental capability through the demonstration flights that Dawn walked through, EM1 and EM2, culminating in EM2 where we have full crewed capability. So EM1 is for us an interim stepping stone. We intend to, one of the key things we're doing between EFT1 and EM1 is we're going on a severe diet. Mass is critical for us. We are losing about 5,000 pounds across multiple systems between EFT1 and EM1. We need to get our mass out so we can support these more ambitious missions to deep space. And so the leaning exercise hits all of our subsystems, and so we just are now in the throes of our PDR for EM1. As we speak, all the meetings are going on where we're updating our designs. We're taking the lessons we learned through building EFT1, further what we learned flying EFT1, folding that into the next iteration of the design for EM1 where we get the mass out, ultimately adding our life support systems so we can support crewed capability culminating in the EM2 mission.
I guess you'll get another run at the reentry profiles, and it's sort of a second run of all the milestones you're testing on EFT1 as well.
That's right. We'll get to demonstrate those systems again. EM1 comes in a little bit faster,
Yeah.
a little bit hotter, and so we'll take the next step.
And Donna, a similar question for SLS. You have EM1 and EM2, and so are you achieving different milestones across the two missions? Or are you just doing a second test, if you will, of the same milestones? What's the approach?
Well, I would say have the same type of lunar mission, so we're testing some of the same systems that we'll test on EM1. We'll test those same systems on EM2. And then, of course, as Charlie mentioned, the things on Orion. I think for us, with SLS coming from ETF1 going to EM1, what's critical for us is that we have hardware and getting our hardware tested. We're really pleased that we have our engine on the stand at Stennis to get things tested. But between EM1 and EM2, we will be basically validating our environments and validating our design with the information we're going to get from our sensors that are on EM1, so that we can make sure that we have everything in place for the crewed flight for EM2. So that's going to be the critical step between EM1 and EM2 for us, is validating our environments.
Yeah, by the way, it's really exciting to see hardware. And,
It
you know, we're a
is.
community, every time I get a chance to go around hardware,
is.
it's just really, really exciting. I could ask a million questions, but let me pause here to see if there are any questions from the audience, because I don't want to be a question hog. Yeah, Jeff.
Yeah, I think it's a great presentation, and I've seen a couple like this week, and they're all about going to Mars. And you know, I keep hearing people saying, we need a mission, we need a vision. You know, if I look at the legislation of the last 8 years, 2005 Act, 2008, you know, and they all talk about going to Mars, potentially. The SLS and Orion were directed to be built by Congress with the view of going to Mars, to enable going to Mars. What is it going to take for people to understand that we have a mission? I mean, what would be
Right.
different on each chart if everybody knew we were going to Mars? They would be the same charts. And yet we still hear this, oh God, we don't know where we're going. Do we have to have it written in stone on a tablet somewhere on a mountain? Or we have a late show or a date?
Big banner.
What does it take to finally let us know that we actually are on the way to Mars? Look at the hardware and all the planning. We just haven't filled in the details. And remember too, that every time we, in the past, laid it all out end to end, in the SCI and Constellation, it died, because it all looked like too much to do. That's why we took the capability approach. So how do we get the communication out there, the awareness that we are on the way to Mars as a civilization?
Does anyone want to take that? I can take a stab at it.
take a shot.
I'll take a stab at this, even though I'm a moderator. You know, I think part of it is perception, and part of it is, you know, quite frankly, what's you're allowed to talk about publicly. You know, and I'm just going to throw this out there. I'm a pretty frank person, so people who know me are. So if you go up to DC and say we're going to Mars, you get people in the executive and legislative branch freaking out because you're not allowed to say that because they don't really want to address it. Is that?
Legislative, it's in the law.
But it's not, you know, you run into people on both sides, right? So I think what I've observed over the last year and a half is there's been and I think this has a lot to do with the global exploration roadmap and the work that's been done there, is that there's been a little bit more convergence on, you know what, Mars has always been the kind of destination, but there's been a little bit more convergence on, you know, what's a real practical way to get there now, and how can you use this lunar space, and what can we do with these tools in order to tie all this together and try and approach a little bit more coherently. And so I think that's helped this coalescing perception that we all have. Like, yeah, we're going to go to Mars. That's the obvious place to go. And even, I think, 4 years ago when we were ending the shuttle program, 3 years ago when we were ending the shuttle program, I think there was still it was a little bit more fuzzy. You know, it seems like we're getting closer to that. But I think communication and just being more as a community mindful about this is our path, and you know, Harley's working with this affordability, and maybe here's a way we can actually do it instead of Mars being always 20 years in the future. I'll just throw that out and we can have a conversation on that.
Yeah, and I'll jump in too. Like I said, I'm just a rocket guy, but you know, I think our problem we get into this is everybody agrees Mars is a long-term goal. I mean, you can't find internationally that is for human exploration is the unquestioned goal. I don't know, you know, maybe some people don't agree with that, but I think there's a consensus around that. But then Mars, to get there is hard. It's going to take a long time. It's going to be a journey to get there. It's going to take capabilities we don't have today. And so then you back up and say, well, we need to take a stepwise approach, and we need to do missions on that journey to get there. And that's sometimes where we get misaligned with different arguments over what we're going to do. So that's the thing I like about the capability approach. I do say, like, our administrator says we're going to Mars. That is inspiring to me. He's an administrator that does that. And I think he's trying to set that tone that, yes, that is our long-term goal. We're going to Mars. And so the things, while we're doing these things and stepping along the way, I think sometimes the trap that we fall into is we say, Mars is too hard, so we're going to do something along the way, but then that becomes an end into itself. So what I like about the way the strategy's coming together now is we have to have credibility that we really are going to Mars. Yes, we're taking this stepwise approach, but the things we're doing are getting us to Mars. They're not just, we're doing something because Mars is too hard to do today. That's my take.
And we're
Yeah,
also
can I-
showing that we know how to do it.
Yeah.
Yeah.
Let me try that. I think I see four things. I think it's an excellent question, by the way, Jeff. Let's see. First of all, I blame the media. I'll just leave it. No, yeah, exactly. No, in this case, although I believe that we have some outstanding space writers, again, Jeff Faust, Frank Mooring, and so on, these guys do a great job. But there is sort of like the second tier that have not done the research and do not probably know that Mars is in fact the stated, for some years now, the stated legislative and executive and NASA goal for Mars. So I think there's some laziness in some of the media. I made two exceptions. Number two is I think I blame the culture that those folks who don't have a great memory about human exploration, one thing they remember is Apollo. And so therefore they are waiting for the presidential announcement. Now, of course, our president has other things on his mind, but he has sort of said that Mars, asteroids are, or an asteroid is our near-term goal. He sort of has said Mars is a goal, but he hasn't really, maybe it's not necessary, but he has not made that statement. Third, we blame some of ourselves. I think they're folks perfectly smart and very articulate, our colleagues, who simply will not accept it and are working on this, that, or alternatives. I'm going back to the moon, even though NASA said, no, we're not going to go back to the moon. So the community has not itself bought into that. And then fourth, one thing we're waiting for is the launch of the big rocket. I think once that is done, with the EFT is the step up to it, once the big rocket is launched successfully in, 4 years, that, I think, will underscore the fact that we're going to go to Mars. That's still 4 years away. So how about that for?
Harley talked about an increase in funding to get to Mars. What's that cost? What's that number to get to Mars?
Oh, my heavens. Actually, I think the best source of that is the NRC report on the future of human spaceflight that came out 4 months ago, something like that. You guys all know we're easy to find. And I think, correct me if I'm wrong, although I have read the thing, they recommend doing some of the same reasoning that our workshop did, a few percent above inflation per year, going directly to this, not across NASA, but going a few percent of NASA's total budget above inflation, going into human spaceflight for going to Mars. Do you guys remember that about right? I think, Jeff, that's kind of what was batting around our workshop. So there you go.
For me, the main reason to go to Mars, maybe this addresses your question. People say, well, oh, we're going to Mars, why? The main reason is to find out about life. And if that's true, then we need to do a lot more exploration before we land on the surface. And I'm especially encouraged to hear Mr. Creech talk about telerobotic exploration as one of the stepping stones. So I'd like to ask, do you agree, or is it generally agreed the main reason is to find out about life? And if that's true, what are the plans for the telerobotic and other precursor exploration?
Shall I just try one?
Yeah, go there.
So if I back up a little bit, Jeff, I really agree with what you're saying, Jeff. I think part of what all we've said here is that we need to start demonstrating a capability that NASA and the international community can do this, can do it affordably, can do it focused in a path toward going forward. I think there are a lot of people that discount that the law of the land says one thing, and I think we just need, and I think we have been, I think NASA has been over the last 4 years or so, really focusing in on being able to demonstrate to the leadership they are capable of doing this. In an answer to your question, I maybe am alone, but I don't think that there's necessarily a primary reason for going to Mars. I think there are a lot of reasons, and I think the architecture is trying to capture all of those. I think the only thing I would hope is that I would try to encourage is that the scientific community and the human community really get aligned behind this and not be in contrast at all. Because I think clearly NASA is doing marvelous things with, great astronomical telescopes first, robotic things next, and then humans after that. We have got to go explore, and I think a big part of it is we don't even know why yet, but we got to do it. And if we focus on one thing, somebody will start taking shots at it and say, that's not my thing, I'm not behind it. I think all of this is great for the country to do.
Any more questions? Yeah, purple shirt.
So the roadmap seems like a very logical, sequential approach to getting us to Mars. Obviously, it's going to take time and money to do that. Do you think that the U.S. government, NASA's approach would change if we heard from another nation that say they were going to launch a Mars mission in 5 or 10 years? Do you think our approach would be different based on that?
Ooh, that's a good question.
Yeah, that's a good question. I think it could. I guess my personal opinion is I don't think we've got the competition of societies like we did back in Apollo, and I think we're going to take a more stepwise, more longer term approach. The analogy I give is, the Apollo program, of course, that's what in human exploration, particularly beyond our low Earth orbit, that's the mindset that most people think of. Well, we had 4% of the federal budget when we did Apollo. We're not going to do that. So, it's been interesting to me working with like the planetary science folks. They don't, make a presidential proclamation and do an 8-year program and they're done. They fly by, they orbit, they land, they rove bigger, they get a sample and come back. Then humans get, it's a progression of learning and building up your mission capability. And so I think that to me is, you're saying you guys were struggling with the definition of sustainable. To me, the definition of sustainable is more that definition, that exploration is more a journey, not a we're going to beat you to Mars kind of thing.
Yeah, I think that's an important point, and I hadn't thought about it before, but the way Harley and Steve talk about it, we're used, and Jeff, this addresses your question a little bit, we're used to that, that's our norm, right? We went to Apollo and we did it in this way. And this way was, the president said we should go to Apollo, and there's a lot of hype and energy, and it was so that doesn't have to be, and it is definitely not our norm today. And so people might not recognize that we're going to Mars because we're doing it in a different norm. And those are really two, I think, perceptive points. So,
yeah, I think let's go back to the example. I think the space station is a much better example of how we would go to Mars, how we should go to Mars, than Apollo is. And Greg back there, other folks, Jeff, you may know this right off the top of your head. The space station program, sum total of everything, is more expensive, corrected for inflation, than the Apollo program, isn't it, by a significant factor?
Well, by inflation?
Corrected to this year's dollars.
Only slightly, depending on how you count it, what you add in the number. Apollo was 125 billion in today's number.
Probably something like that.
125 billion.
Stations about 100. Well, yeah, but if you include all the international partners and the shuttle launches and so on, I think, whatever, comparable. And it did not require a Cold War, the beginning of the Cold War, it did not require a Cold War competition. It was born out of a Cold War cooperation and continuing post-Cold War cooperation. Seems to be really successful in terms of a political and financial and so on budget.
It also required a domestic consensus. And then, remember, we Apollo's launch station by one vote in 1993. And by 1998, we were exceeding, the station was supported by
So Jeff, are we doing what we need to do to continue that experience? Pardon?
Not right now.
So do you have ideas of what we should be doing to do that? Is it just communication?
Well, it's coordination and coordination of effort and communication of the results of that effort. And we've talked about that, I think. You said that we need to show results. And you're doing that, but we need a coordinated way to connect all those dots to those lines that lead to Mars.
So one could argue after EFT1, there's a chance for a results/communication coordination effort. After EM1, there's another chance for that kind of a coordinated communication. And maybe that's an action item for us to think about that as we leave the panel. There was a question, I think, all the way in the back.
I would say that one reason for exploration is that you're given the right to set up a permanent presence and go someplace to stay. And I've heard, and I don't know how true this is, but I've heard that a lot of the international partners are interested in going back to the moon. And I'm curious what you all think. Is some of the resistance or lack of support you see on the Mars mission because people view it as potentially just providing footprints again? Not that we have the wherewithal to go there to stay long term. Is that maybe why there's interest in going back to the moon? Or
You know, I don't think it's that. My perception is that, remember, for the international community, they're not going back to the moon. They're going to the moon for the first time. And so I think it's back to this discussion of, we know we need to take some logical steps along the way, and they think that's a logical step for us to take. And so they don't argue that, sorry, Harley. They don't argue in terms of the long-term goal. It's back to what I was saying earlier. What we argue about is the interim, and so I think that's their perspective.
And correct me if I'm wrong, though, the way Larry was discussing the Orion, and Charlie and Larry, you can both address this, the Orion can, if, you know, depending upon how the international community agreements progress and when a deep space hab may or may not arrive on the scene provided by an international partnership, the Orion can be kind of chain ganged, if you will, to provide that capability so that the U.S. could do some things in cislunar space while we're syncing up schedules with the international. So there's actually a couple of flexible ways to reach this point. Is that correct? Yeah.
Larry, you can add. I guess I wanted to kind of emphasize what Larry touched on. Maybe I'll emphasize it, though, is the multi-purpose aspects of the multi-purpose crew vehicle. We like to call it Orion because it flows off the tongue a lot quicker and easier. But this vehicle, we took all those different missions into consideration. We looked at cislunar missions, lunar missions, asteroid retrieval, ultimately Mars. And we looked at all the key driving requirements that would affect the spacecraft's architecture: re-entry speeds, life support, power, delta V, deep space communications. Taking all the missions, all the key driving requirements, we grab those, and those form the basis of what is today's MPCV Orion vehicle. So I feel confident that the spacecraft we're building and testing can support a wide array of different missions. And so I personally don't lose a lot of sleep because that there's not a very clear, defined up for the next 30 years pathway, because the systems that we're designing with SLS and MPCV are flexible enough to accommodate a wide array of different ways to get ultimately to where we want to go.
I don't want to lose the second half of your question. So in the context of the global exploration roadmap and the missions that we're talking about, has there been discussion about what we would do when we get to Mars and what context we would go? Like, would we send a mission a year? Is there the science community, are they involved in this telerobotics? Are those kind of conversations going on?
I don't know the answer to all those. I know that the idea is a sustainable missions to Mars. Again, it's not go put a flag, not go drop a flag and be done. I do know that, and have been involved some, that there is definitely discussion across the human and robotic community. And so, like the Mars sample return and lunar sample return, one I specifically mentioned, and we have both communities involved in that trade and looking at that study. So definitely.
Okay, so I think we got both parts of your question there. Yeah.
Could I go back just
Yeah.
a little bit to add on what Charlie said? I think what we're learning when we put together EFT1, laid out some objectives for what to accomplish. Charlie said 80%. They were really focused on what we could do in the near term and be a stepping stone toward the future, not be an end game, as Steve mentioned, and really aligned with moving forward, right? And I frankly am amazed at all the other things that happened during that process in the collaboration with what people have piled on and accomplished in that process. And one that I think we were thinking about, and we were, I think, Jeff, telling Congress about, is this team could also do something within a constrained funding profile. So we took what was a reasonable amount of money, and the team allocated effective things to go accomplish. And I believe we've proven that. So I think we can discuss how much money it takes and what mission it is, but I'm afraid we get all tangled up in the uncertainty around each of those. And like Charlie said, we're building a machine that can keep moving forward. We don't know where forward is yet. We're exploring. But don't do stupid things and do it within an affordability line item. I think that's a significant accomplishment that we've done in the last 4 years.
Let's see, right here.
To get to the Luna question again, it seems to me in the plenary session earlier, some of that was addressed because the risk of having us either or, you get folks that want to go to the moon with the catalyst program. There are folks that are going to go to the moon, like it or not, commercial people of the countries want to. And maybe an analogy could be what we're doing now with commercial and exploration, that, hey, we've done Leo, commercial guys can do that. The NASA has to be on deep space. But the closer we get, we find that there are complementary.
No, I think.
Is that
I think you're right that there's going to be opportunities. A lot of the global exploration roadmap studies now are looking at those lunar surface kind of ways you would do that. I envision we'd contribute Orion and SLS to those missions. They're staging through that deep space hab that I talked about. So you're right. Every country doesn't have to do everything. And there will be opportunities, I think, with others, like the Catalyst, that are going to be interested. So.
Back in the back corner.
Moving over to a technical question for a second for Larry and Charlie. AvCode has its own inherent issues and extremely labor intensive. And I was curious if the program is going to do a relook at AvCode after EMT1, lessons learned, the level of effort relative to maybe CIRCA or other reentry materials, relative to cost, flight rate, that type of thing.
So Charlie, let me try to do this first, and I hope that we will be very collaborative in this process. Right? But
I can withdraw the question.
No. I love that question. All right, and I think it's another example of what we've done in the recent past. So, started out at the beginning of the program with an advanced materials program to determine what material to use. Numerous materials, hot structures, ablators, focused down. Very close between AvCode and one other. Very significant engineering review boards, trades, program review boards, where to go, because it had cost, schedule, and risk implications, and clearly one did not win in any category, right? NASA made a decision, we move forward. Then as we move forward, lots of analysis, forgive me, Charlie, by paralysis. We're arguing subtle thicknesses differences between a heat shield for low Earth orbit and a heat shield for the moon. The team got together and said, stop this, design the heat shield that we've got and move forward, get test data, narrow the uncertainties, and move forward. What we're doing now could be adequate for a cislunar return or not. Get the data, therefore another feed into this flight test. So it's an example of about 1,000 things we're doing on Orion to balance the risk across the entire program. Heat shield may change. We're going to learn a lot at the end of the year. We're redesigning the heat shield anyway to save part of the 5,000 pounds Charlie's talking about, right?
So all I would add is some specifics with regard to your question about, are we re-looking at AvCode? Yes, we are. We learned a lot building this heat shield that I showed you. We're going to learn a lot more flying it. We've instrumented this heat shield with about 68 thermal couples throughout it. We're going to be taking the data. We're going to be monitoring its performance. We're going to use it to update our ablative models to see do we know, got the right thickness of this? What's the capability of it? We have very limited ability to test things like this on the ground. Currently, NASA has one ArcJet test facility. It's at Ames near San Jose, where we can approximate these types of environments we see upon the heat of reentry. You can't get all of them at the same time. You've got heat, you've got pressure, heat flux, radiation, environment. Pick one, test that, but get them all together, the only time we can do that is on a flight test of this nature.
Of a large size.
Of this large size. Yeah, when we test in the ArcJet facility, we're talking very, very small level. And you've got scaling issues. So we're going to learn a lot. We have an architecture study that's going on as we speak to look at different permutations of AFCOAT. You mentioned very labor intensive. It is. If you're building a heat shield every 6 months, it's one thing to keep a workforce at a level load to build a steady stream of heat shields. If you're flying every few years, that's another thing. You've got workforce fluctuations, hard to keep that critical skill resident at various contractor, for example, that's doing this work for us. So we're looking at more sustainable types of architectures as well that could be more affordable, maybe permutations of these heat shield materials that are more conducive to like a block, a tile-ish approach where you're not as labor intensive in the build. Hopefully that addressed your specifics of your question.
Bill?
I want to make a few observations that introduce some controversy in the room, and then get your reaction. We have a program we're talking about no less than 20 years to be successful. We have people not just technically on track, but politically on track, not get leadership that gets burned in different directions. And what you see out there is an environment that is rife with opportunity to go different directions. You got Inspiration Mars. You got advocates of one-way missions to Mars. You have Elon Musk out there saying he's got a much better solution than SLS for how to get everybody to Mars, and he would like to deliver lots of people to Mars. So there's all these alternative strategies, drastically different. The only common message is that Mars is there. And you have politicians that will latch on and have been latching on to specific alternative programs of this type. And, how do you keep on this message for 20 years rather than one of those other things taking off for the next 5 years and then something else for 5 years after that, bringing you back to the situation where you haven't achieved any result in 10 years of life?
Thank you, Phil.
You want to take that?
I'd love to.
Go,
Can
Larry.
I?
Go.
Can I? Okay, you'll probably throw me out of the room, huh?
Go for it.
Okay, let's see. Jeff, help me here. I think the political community in this country is very well aligned and getting more aligned. You mentioned the one vote on space station. I don't think Congress has gotten close to a one vote on authorizations or appropriations bills. I think they are just watching this team and does it perform. I think it's a compliment that there are a lot of opportunities, Mars Ones, one-way missions, Elon Musk. I think that says there's a real opportunity here to do this. So I think that's all good news. It still comes back to a lot of thought has gone into the plan going forward. You can criticize it for how expensive it is, but I think I'm biased, there's an awful lot of experience about why it is as expensive as it is. I think the element of it that says this NASA team is metering this approach going forward. We'll get to Mars when we get to Mars, depending on the funding, but we are going to very meticulously and carefully move forward and make steps forward. If we're wrong, and Elon or somebody else is right, bless their heart, and let's get on that path and get going forward. But a lot of what I dislike intensely is we make a plan, we have a lot of people vote on the plan, they determine the plan, and then 4 years later something changes and you throw that plan out the window and start over again. I loved Wayne Hale's comment that said, if you give an engineer unlimited budget and unlimited time, he'll never finish anything. Because there's always a better idea, throw it out and start over again. I think we have demonstrated in the last 4 or 5 years that we're meticulously moving forward on a good path. If we're wrong, there are plenty of ways to go fix it and redirect the path.
Okay, so I know I'm the moderator, but I have a comment. I think we need to change our mindset. It doesn't have to be an or, it can be an and. As new capabilities come online from the commercial community, from wherever, whether it's a new rocket, or it's a widget that goes into a life support system, or a new ablative material, I mean, why can we not incorporate those new capabilities into the global exploration roadmap structure and move forward appropriately? You know what, we have to get out of this mindset where, and I realize there's competitive forces at work and it's a limited budget, and yeah, that we all work like that anyway, right? But why can't we change our mindset so that it's an and? Great, you've got new people entering the space industry. I think that's wonderful. Yes, we're focused on Mars, but don't forget the LEO stuff and the comment that somebody's going to go to the moon. And why can this all be done in a complementary fashion? We need to put our brains into play and get out of this or mode and get into an and mode. And I think we can do it. I mean, we're a community of can-do people. And I think with, you know, we think about this, we can figure out a way to make all this happen so that we are maximizing the output for the benefit of space exploration and space presence for everybody. So I think we need to think of it as an and. Sorry, I just couldn't help myself.
Yes.
Okay, another question. Don.
Steve, on your global exploration roadmap, one of your charts showed a lane for science missions. And Harley, when we had our 40 Mars workshop in December, we spent a fair amount of time talking about the importance of having science objectives in all of these human space exploration missions or pathways. Do we need to have the same level of discussion on integrating with the science community as we had in discussing international partners?
I think so.
I think that'd be beneficial. One thing you'll know, if you've been in any of the, like there was a forum for the Global Exploration Roadmap at APL here a while back. You know, Kathy had the science, stakeholders in that discussion. So I think it's key. You know, I really do believe we need to be integrated with the science. I mean, you're from the science community, so why don't you comment? But I think so.
Oh, yes. In fact, thank you for bringing that up. One of the recommendations that came out of, and you probably remember this, that came out of the last workshop was don't bring the scientists in at the end and tell them what you're going to do. And you guys will remember, Jeff and I guess Sam and Sandy have left, that we didn't have that many scientists there, but they were, I believe, made serious contributions to what could be done. Very, very useful in critiquing this, that, and the other thing. So the science as an integral part, as you pointed out, of the process. A quick note, in the second workshop, the upcoming workshop, one of the breakout sessions is going to be, however we word it, what are the priority science goals that are enabled uniquely by having humans on the surface or in the immediate vicinity of Mars? So yes.
Yeah. All the way in the back?
I have a comment, I guess an unrelated question. I think it's representative of both for somebody in Congress had a motion or a bill that they wanted to bring up to sever NASA's direction of budget from 4-year political cycle. And I think, everybody at this conference is from a different part of the country. We should all be writing our Congress people to support something like that, trying to get away from potential changes every 4 years. Then the unrelated question, I saw in the global roadmap, the Mars landing part had four SLSs. Has there been any consideration of leveraging some of the commercial heavy lift capabilities that come around in the roadmap that maybe speed up the time it takes to go on heavy Mars?
I think like Sandy said, we'll look at the and. The mission scenarios I've seen are mainly, as you saw this morning, the latest thinking is through cislunar space as kind of a staging point. And so you can imagine while you'll need multiple SLS 130-ton kind of launches to get all that system there, there's going to be other capabilities, international and commercial, that can help support that kind of scenario.
Yeah, I think the roadmap will probably be a living
Yeah,
document that's altering
absolutely.
as capabilities come online. There was a question up front here, yeah. Oh. You first, and then we'll go behind you, so. thanks.
Yeah, I'm glad they're asking about the commercial community, because we're doing a lot of that activity, trying to take advantage of capabilities. Specifically, I wondered about non-SLS or non-Orion payloads on SLS. Anything going on there where maybe a commercial user might be interested in an SLS trip?
So exploration. So we've
Or could be market exploration.
yeah.
Or commercial.
So other uses of SLS. So we've always talked about SLS is we're building it for exploration. You know, we can build it to be the Mars vehicle and to do all these missions in between. But we've always thought it's a national strategic capability that others can use. By policy, we're not going to compete with commercial capabilities that are out there on the market, obviously. So it has to be something that comes along that really needs that performance, volume, et cetera. The areas where I've seen that working that for SLS, where we're getting more traction, is like the outer planets. You can do direct missions to outer planets and dramatically reduce the trip time. Obviously, the big telescopes, is an area with volume. And really big one. Harley gets excited about that. Commercial, we have not really had any commercial other than we have, of the Bigelow HAB, I have talked to Mr. Bigelow, and there are versions of his, HABs that would need an SLS capability, both volume and mass, but I haven't really talked to anyone else.
And you're saying-
One of the things that Larry said, we have to perform as we go along. The astronaut panel last night was fantastic. And one of the things they all resonated with is an honest assessment of risk. They know all of this is hard. Difficult tendencies have to be evaluated. But are we taking an honest assessment of risk and balancing that against the have to perform?
In what context? In SLS and Orion, or the whole exploration roadmap? or-
This entire roadmap, we're bound to learn something with the parachute didn't open, but that was a small piece of the entire task. So that's a pretty success. But the general public isn't a scientist or an engineer. So when things happen, are we preparing them for when we go through this process? It's a learning process.
I think that's a good point that, NASA's not here to do the routine. We're here to reach new heights and reveal the unknown, not the known. And so in doing hard things, that video this morning kind of, the parachute didn't open. Okay, nobody went, boo or anything. We're doing research and development. We're learning. We're reaching new heights. And I think you make a good point that's with our stakeholders and the public. It's going to be important to how we communicate that.
Yeah, it's, again, here she comes again.
Yeah, come on in.
The interesting thing about that is we in this room, we understand, in a way that the general public does not, how risky it is what we do. We make it look easy, right, because we're really good at what we do. And people completely took for granted that shuttles were going to launch, and now that Cygnus is going to launch and Dragon's going to launch. And we understand that there's a lot of hard work that goes into making it look that easy. And so our understanding of the risks involved are completely different than the general public, which is, I think, where your question is going. That's compounded by the fact that our culture has become more risk adverse. How many of you who are my age, which is very old, rode bikes without bike helmets on when you were young? Now if you see a kid riding a bicycle without a helmet on, it's like, the world's going to end.
Who's his parent?
Yeah. So our culture is actually becoming more risk averse. So we as a community, and every one of us has to do this, have to be prepared to communicate to our friends and the general public anytime about, hey, we are controlling the risk as much as we can, but this is a risky business and it's really important, and please don't freak out when things go wrong, because this is a learning process, and that we're doing this all in a very methodical, mindful fashion. So we all have to be ambassadors for that, because that's a constant battle that our industry is going to have. That's never going to go away, because we are at the pointy edge of the spear. because we love doing it, and somebody needs to be at the point of the spear, and we just have to keep communicating that. And that's a never-ending battle.
I want to challenge something. I said, again, this is coming from the astronomer, probably the least risky profession on Earth. I wonder, is the, sitting in the lab, yeah, exactly, stumbling around in the dark. Could hurt you. Exactly. I did lose my office mate as a postdoc who got crushed by a telescope dome, so it isn't entirely.
It's not entirely risk-free.
That wasn't a joke. In any case, is the country really risk averse when you throw in the value of whatever activity that you're putting? Now,
Maybe not.
good example of, since I do bike a lot and I do wear a helmet, because I don't want to die or get badly injured by biking. I mean, that's just by bicycling. And yet at the same time, I read about loads of my fellow citizens who undertake very risky activities, not just, for example, astronauts, but mountain climbing, road racing, deep sea, free diving in the ocean, because they think it's, for whatever reason, they think it's valuable to them. It is worth dying for. It's something I don't understand in those particular examples, but it is something that is worth dying or facing serious physical harm. I think going into space, going to Mars, can be or is worth the danger, and I think
Absolutely.
I think the rest of society, properly educated and properly
Agrees.
Yeah, exactly.
Yeah, I don't disagree with that, but it gets back to communication.
Exactly.
It gets back
I
to
mean, get
communication.
right back to Jeff's first question.
I'd just add to it that what Steve said about the parachute and other things that are going on, what we've got to do is not fail at the things we shouldn't fail at. We've got to do all the things we know how to do well. Don't just overlook something and fail. If we fail doing something hard and we do the right mitigation approaches before we put humans involved, that's the right thing to do. I think the public admires that.
Yeah.
Yes, back in the blue and white striped shirt.
What are we illustrating on, since we're doing a long-range, this with any long-range technology, especially with Mars, which is the whole feature of human species to think about, are we illustrating the benefits that we get from space that people see every day? For example, if I'm saying, well, what do we get out of the column? I point right at this or at my funky high-tech glasses right here, because these both were benefits out of the Apollo program. The microprocessor that's in here, the small radio transmitter that's in here, and the small antenna that goes with it. These are both benefits that came out of Apollo directly. So the question is, are we doing enough to show that, hey, by going to Mars, we will probably see some pretty cool stuff. Just if this is what we are from Apollo going to the moon, just think about what we're going to get from Mars.
Yeah. You want to take that? Charlie?
Well, I have a comment on that. So that is where, although true, that's a dangerous thing to rely on for two reasons. Well, it's dangerous for a couple of reasons. One is NASA tries very hard, and our industrial partners try very hard to make that case. And just not, I mean, there are the spin-off articles and so on and so forth. It's not really been that successful. Also, it certainly would have been a lot less expensive to invest directly on microprocessors than to spend the Apollo program with the expectation that a spin-off, if you want to build microprocessors, which loads of folks were interested in doing at the time, or whatever the equivalent is. Oh yeah, no, there were folks in the military and their partners who were really interested in microminiaturization, and it would have been much less expensive. There will be spin-offs in going to Mars, but that's not the way to get the spin-offs. I don't think that's an argument that works all that way. We should try it, but I don't think it works that well.
With using eventual partners with benefits also comes with challenges with that, as we've got the station, the current environmental question, just kind of curious if you know,
Good beer and German. What's wrong with that?
considerations for that, or is this kind of one implementation for those challenges?
I'm not as, you guys want to answer that? That's the thing that's directed me. I'm not sure the answer to that. I mean, I do know that, we've got a lot of lessons learned from Station. But, even though there's going to be challenges there, I think that the consensus is it's going to have to be, and it should be, an international endeavor. But you're right, that's something that's going to have to be managed and worked through.
I mean, Steve's right, but again, the space station seems to have solved a lot of those problems for us.
And it's a really strong partnership to move forward on because we kind of understand each other, more or less. Any other questions? Well, oh, wait, did I see a hand?
Well, I have a question for Steve.
Okay.
I think one of the the GR is going great. I mean, it's remarkably successful to the stage. How do you see, and what is the plan? I think this is a little bit of a variant on Sandy and what you asked. How do you see getting from where the GR is going right about now to formal commitment by the space agencies to deliver on what the GER comes out of?
Yeah, and remember this, the GER is more of a coordination forum, so that gives us a roadmap that we can have, that agencies can have that discussion. So the way I see it playing out is that, and as Charlie said, we have an international partnership on the service module already. That the same type of things will happen is that the GER will help us identify different capabilities that are needed and different partners that are interested in it. Then they will study, the implementation of that to do different missions, and then that'll become an actual international agreement and will be implemented agency to agency.
In sort of a piecewise way?
Yeah, that's the way I see it. That's the way we're seeing it, yeah. We don't see, maybe in that case, we're not seeing at this time a great global, now let's make sure we got every piece to Mars subscribed for right now. We see it as it's going to be a journey and it's going to evolve as we go along, that different missions that are formulated and different capabilities are developed to do those missions will develop over time.
Okay, so I think we can probably spend a moment making some closing remarks because we're running close to running out of time, and then wrap up the panel. So if you guys have any closing thoughts based on any of the conversations, that would be great. Well, Dawn, we can start with you, and then I'll wrap it up after that.
I would say that as a panel member, but also just a space enthusiast, I've really enjoyed serving on the panel with these gentlemen. I've learned a lot from serving up here with them. But I would say, from my perspective from SLS, I'd like to piggyback on what was said earlier, is that we're really designing our rocket to be flexible to whatever mission comes forward. We know we have politics involved, the mission or the goal may change, but SLS is being designed to take on any mission that our Congress or politicians may come up with, and I think that's a real important point for SLS and Orion, that we are being flexible in our design to be able to partner with international partners, commercial partners, and that's something that we're really putting forward in our design as we go forward, and so we're really pleased with that part of our mission.
Excellent. Charlie?
Well, I would just like to thank everybody for coming out today and listening to what we have to say. I love getting to share where we are. We're really proud of what the team has done getting to this point. It's been a long road. We've suffered a lot of, speed bumps along the way, from Constellation getting canceled several years ago, emerging from those ashes and coming up with an exploration architecture that you saw the first pieces today that are being built and are going to be flying soon. So we think we've come a long way. We're excited about playing a role as a key component of an exploration architecture, and like Larry says, I think we need to deliver and provide confidence to the public and Congress that we can do what we say we're going to do at the costs we say we can do it at.
Larry?
Yeah, I don't know if I can add to what you two have just said, but I am really encouraged. I'm encouraged that there's so much excitement there. I think there's really a trend toward excitement about what's going on in space for all good reasons. Just like we're not going to have one particular path to where we're going because we don't really know where we need to go yet, there's also not one particular path to how we're going to get there. We're going to use a lot of other capabilities, international and commercial, And again, I think in the last 4 or 5 years, we've really demonstrated the capability to do that. There is a tremendous collaboration between the low Earth orbit commercial operations and the deep space long duration. And so I'm really encouraged by all of that. I'm encouraged by Congress. I think Congress is very stable in where they're going forward. And again, we just need as a community to perform and align the scientific community with where we're going. Use space station as a stepping stone to probably an interim point on the moon as a stepping stone. Learn all these, prove all these capabilities so we can do it within a reasonable amount of risk. So I'm really excited about where we are now and where the near term is going to hold.
Good. Yeah, I'd like to echo what Dawn said. This is a very enjoyable panel to be working on. Thank you, Madam Moderator, for leading us. And then a couple of quick things, again, which I've already said more than once. Don't leave the science or scientists out of the process. And I think the space station, to repeat, I think the first thing that was out of my mouth, space station is an outstanding model for how to go forward.
So being on the end, I think most everything's been said. I would just add, I do think the next few years are going to be really exciting. It's kind of hard to get the public and others engaged and excited about going through PDR and going through CDR. You know, while that's exciting to us in this room, it's not very visual. It's not very, you know. But when EFT1 is going to be great. You know, we're going to have hardware. We've got hardware coming off the line for SLS when we fly M1. So that's, you know, we're moving into a really historic, you know, and then also commercial cruise going to be, down select's going to be this, or multiple select's going to be this fall. We're going to be moving into a really exciting time of capabilities to be able to do these missions for NASA. So I think it's going to be great.
Well, first of all, let me thank you all for participating and just leave us with some thoughts, you know, to go over some of the points that we made today. I think what we've seen today is that we have an extremely engaged international community working towards a long-distance goal of Mars with some ideas for how we get there, and that the importance isn't as much as in the journey as it is in the destination and how we all work together. And parallel to that, the United States is developing a domestic capability, and soon we'll have a test flight, which is oh so exciting for those of us who love to see stuff launch, and to start proving out and demonstrating these capabilities, and these capabilities are being built in a very flexible way. I think a point that we learned today is, you know, we need to be conscious as a community that as these milestones are passed, and they are passed successfully, that we need to have a coordinated communication response to point out to the world that says, hey, look what we're accomplishing, and we are on this path to Mars, and we have a plan to do it. And oh, by the way, the paradigm might not be what how the Apollo program did it, but we are nonetheless on this path. And so I think that might be an action item for us as a community to go out afterwards, but that we have some great tools in the mix. We have some interested international partners. We have a good model on the space station program. We have a methodical approach. People are paying attention to affordability and sustainability. And all these taken together means, wow, we are so much in business going into the future, and look what we're accomplishing. And it is hard to see that in the planning stages, but now we're getting out of the planning into the testing, and we'll have a good way to communicate this to the outside world. And so every one of us has to be ambassador for that communication. So I'm really encouraged, and I'm very excited, and I really appreciate having gotten to spend some time with you guys and get caught up to speed with what was going on, because there is a lot going on. So let's give our panelists a round of applause, and thanks them for their time.